Today we're going to be talking about Math 3, Unit 9, and we're just going to get a little overview of this geometric modeling chapter. And so what I want to show you right now is the actual textbook. This Unit 9 comes from Chapter 10 primarily, and if we look at the topics that we are covering and the sections of the textbook, I can tell you that 10.1 we're not doing constructions. I've done them thoroughly in Math 1 and Math 2. We will be reviewing ratios, surface area, and volume, which they've done quite a bit through middle school and again reviewed in Math 2. So this should be a short review lesson, not a full-out teaching for the first time. In 9.1 we'll be doing volumes of solid figures, and that one of the things that's different is to think about if you needed to find the volume of the whole and then subtract off the piece that is missing. And that happens several times, the volume of the whole and subtract off the piece that is missing. And one more time down here. And so that is a different thing they don't think they've seen before. It's not a terribly difficult application. Then density and design problems are both from section 10.2 in the textbook, solving density and design problems. The idea in this entire chapter is to be using our volume and area formulas that they've been learning through middle school in application situations. And so density is a formula that uses volume. Sometimes they'll need to find volume to be able to do that. It's a really friendly lesson. I'm going to make a video on it because you probably haven't taught that before, but you'll see it's a very simple formula that you can apply and work forwards and backwards, and units will be an important thing to focus on that it's grams per cubic centimeter or something like that. Design problems in the textbook focuses entirely on if I'm going to make a box that holds 90 liters or 90 cubic units or something like that, what would be the least surface area? That's consistently the question they ask in textbook. Anytime you're asking for the least or the most from an equation that is quadratic, you're asking for the maximum or the minimum. And so I don't know if you remember in Algebra 2 and in Advanced Math, if you've taught that before, we did a lot of problems that had to do with finding the maximum or minimum in a quadratic situation. Last year they didn't do those in Math 2. This year they will be doing some. So we think next year the kids will have covered that in Math 2, and we will review it during our Unit 7 potentially. So this won't have so many quadratics because quadratics doesn't really fit in the whole area volume situation. But there are problems that use that idea of max and min that do have to do with area and volume. And so we'll do those, but we'll also do some of the more traditional Algebra 2 type topics in that. Because that doesn't flow with the rest of the chapter, the design team is debating moving this to the end of the unit just so that everything will be about area and volume until you get to that one, which like 2/3 of the problems really are not about area and volume. The next piece is similar figures and scale factor, and that is covered in 10.3 and 10.6. So this just has to do with perimeters and area. This one has to do with also volume. We put that together into one lesson, and so that would be 10.3 and 10.6. There's worksheets on that, but you can use the video resources and whatnot from the book for the students to be able to access. Space figures and cross sections would be from 10.5, and again we have a worksheet also for that. And then modeling with geometry is a section that you won't see in your book, but we're working on multiple things. This is one problem that they're working on with that. That's using volume. There's another one that is just area about a baseball field. I'm trying to find it. Here's some diagrams that they're looking at using in that. That worksheet is not complete yet, but you can see geometry all over something like this. And so, and then it's going to come right at March Madness time. It'd be nice to do a basketball problem. So anyway, that's just kind of an overview of what's in the chapter. And I am planning on doing a video on density, on the similar figures and scale factor, and possibly on a modeling, like the tasks. If you have any other things you're really worried about and you email me, I'm happy to try to put another video together. So I wish you the best of luck and enjoy this unit.